Hello, in this video, I'm going to explain how to assess whether linear motion is occurring during a motion analysis or during a movement analysis. So first off, what is linear motion? It's simultaneous motion of a system in the same direction by the same distance along an axis. So I want to clarify here that when we talk about motion of a system, that system can be defined in so many different ways. We could be talking about the entire body. So in that case, linear motion could be like travel from point A to point B, so like walking across the room. But the system could also simply mean like a joint or the spine or the head, the center of mass. Like the system could be whatever we define it to be. So if we're watching a movement and we're trying to assess whether any linear motion is taking place, you need to think not about the entire body and whether the whole body is moving from one position to another, but look at the video or look at the movement that's occurring and look for anything that you see moving along a linear path. So a linear path, that could be a straight line or it could be a curved path, as long as there isn't rotation that's occurring around a fixed axis, then it would be angular motion. I also want to remind you that linear motion can happen along any axis. So the x-axis, y-axis, or z-axis, or any oblique axis that is splitting the difference. As long as the motion is occurring in a straight line or along a curved path, but without rotation, then it's linear motion. So like an elevator moving up and down, that's linear motion. It doesn't have to be forward and backward. Can be up and down, forward and backward, side to side. And again, it doesn't have to be the entire body. It could be any component that is part of the body. Okay, so is linear motion occurring? Look for any part of the body or an object involved in the movement and look for anything that's moving along a linear path. So for most movement analysis, so like if we're analyzing some kind of exercise or movement, most of it is going to be angular. So most of our joints are moving in an angular path where they're fixed. There's an axis that's fixed, and then the bone is rotating around that fixed axis. So most of the analysis is going to be angular. But in any movement analysis, there will be some linear motion that you can point to. So like in our picture of a deadlift up here, the bar is moving in a linear path. So even if the joint motion that's taking place to cause that bar to go up and down, that joint motion is angular, but we could still look to the path of the bar and point out that the bar is moving in a linear path. Or in our picture at the bottom, we've got somebody doing a pull-up. So although the joint actions to cause the upward and downward motion, those joint actions are angular, but the path of the whole body going in the upward and downward direction, that is an example of linear motion. So if you're trying to find the linear components of your analysis, just try to keep an open mind, watch the movement, and look for whatever is moving in a linear path. Is the whole body moving in a linear path, like running? Is just the center of mass moving along a linear path? Like maybe someone's doing a squat and the center of mass is moving up and down, or the pelvis could be moving up and down. Is the head moving in a linear path? Is an object like a barbell or a dumbbell or something else? What is moving linearly? So in just about any analysis, you can come up with something that is following a linear path, even if that linear motion is occurring because of the angular motions of the combinations of joints that are causing it to happen. Like if we take gait, for example, that's usually something that students understand really easily, is that through gait, I can walk from point A to point B, and the movement of the entire body is going in a linear path. That's linear motion. But that linear motion occurred as the result of combinations of angular motions that were taking place at all of the different joints that propelled the body from point A to point B. Okay, so in a lot of cases, the linear motion that's occurring is being caused by angular motion of combinations of other joints. But in any case, that linear motion is still occurring, regardless of what axis the linear motion is taking place on or what caused the linear motion. There's some kind of linear motion in pretty much every movement analysis. All right, thanks so much for watching this video, and I hope you have a great day.